Hello everyone, welcome back to my additional math channel. The purpose of this video that I created is to help you to clear your confusion about the solution of triangle, which actually having ambiguous case. So as you know, ambiguous case of triangle is quite confusing. So I'm going to explain to you using the video to clear your doubt and confusion about the solution of triangle. So let's get started with the class. Have fun!
.21 cm, angle F is 45 degrees, and the length of EF is 24 cm. Okay, our task is to find the length of DF. Okay, before anything, this question, I'm going to tell you that this question is a special case of the law of sine. Okay, it's so special that it has its own name. It's called the ambiguous case of the law of sine. How do we identify that we are dealing with an ambiguous case of the law of sine? Whenever the question gives us two sides and one angle, okay, two sides and one angle, or SSA for short, okay, it's two sides and one angle, we need to be extra careful because we are dealing with an ambiguous case of the law of sine. Okay. So what's so special about this ambiguous case? Okay, depending on the information given to us in the question, we might have one triangle, or two triangles, or even no triangles at all. And so how is that even possible? Right? Let's talk about the concepts first before diving into this question, and let's get started. Okay. Whenever we are given two sides and an angle, again, we are dealing with an ambiguous case. Okay, so let's say in the question we are given some length b, okay, of a triangle. We are given some length, let's label that as b, and we're also given an angle a, so we can't change these quantities. Right? These are quantities that we can never change because the question gives us so. And we're also given another side across this angle. Okay, across the angle given to us, we will also be given an angle. Also given a side, and since we have to match the letters, I'm going to label that as lowercase a. Okay. Now, these three quantities are something that we can never change within a question. Okay. Now, you might wonder, why am I drawing it like this? I'm not even drawing a triangle, right? This side is so short that it doesn't even touch the base of the triangle to make a triangle. Right? That's exactly what I'm trying to get here. I'm trying to say here. Okay. Because the question only gives us quantities of these things here, only the magnitudes of the lengths and the angle, right? Without any diagrams, we wouldn't know whether this side that's given to us is actually long enough. Whether it's really long enough, right, to touch the base of the triangle. It may not even touch the base of the triangle. It may not even form a triangle like this, right? So how long does this side have to be in order to make a triangle? Well, this side would have to be at least as long as the height of the triangle, right? In order to form some kind of triangle. That's a right triangle, okay? So if this side here is as long as the height of the triangle, or the altitude of the triangle, I'm going to label that as h. If A is as long as h, then we have one triangle, right? So let me summarize what I've just said. So if A is so short that it doesn't even touch the base of the triangle, right? If A is shorter than H, it can't even form a triangle. So if A is shorter than H, if the length of A is less than the altitude or the length of H, we won't have any triangles. Okay, so that's one case. Now, if A is exactly the same as the length of A is exactly the same as the length of H, we have one triangle, exactly one triangle. And we know that if A is exactly the same as, if the length of A is exactly the same as the length of H, we have one right triangle, right? This angle here is 90 degrees. We form a right triangle if A equals H. The length of A equals the length of H. Okay, so we have just covered two cases. Okay, but there's a little more to this one triangle case. Okay, if this side length A is longer than our side length B, right? Let me grab some props here. Okay, if our side length A, if this is A, if this is the edge of A, right, is longer than B, which is clearly so. Okay, if this edge here, I'm gonna pinpoint this end of this edge to this corner. Okay, and as we rotate it like this, right, the only spot that this end of this edge would touch would be somewhere around this region. Right, let me extend the base of this triangle. Okay, the only spot that this end of this edge would touch while this point is fixed on that pivot, okay, would be somewhere like this here. Right. If we move it to that side, right, if we move it to this side, this point here can't intersect with any points along this base. Right, the only point that it intersects would be this point. No matter how we move it, there's only one point. Okay, so if we connect this dot here with that point, we form one triangle. Right, that's the only triangle that we can get if the length of A is longer than the length of B. Okay, so we've made another situation for the one triangle case. Okay, when A is longer than B, we also have one triangle. Okay, now here's the most interesting case here. By interesting, I mean it's interesting because we have two triangles. Okay, we have two triangles for this case. So how do we have two triangles in one configuration? Well, because we have two configurations. That's how we get two triangles. Let me take away this side here and this dot. Okay. Now let's test out the sizes. Okay. If now this is the side length. This is the side A. Okay. This length here is longer than H. Yeah. And a little shorter than B. Okay, longer than H, but a little shorter than B. Then as we move it along like a pendulum, having this point here fixed at this point, right, is a pivot point. Okay, as we swing it, we'll have two intersection points. Right, watch carefully. This is one. This is one. Right, as we swing it, you have another one here. Okay, so let me highlight the points. Okay, as we swing it here, this is one. Swing it further, I have another one here. Right. This end of this edge A, if this edge A is has a length between the length of the H and the length of B. Okay, if the length of A is in between the length of H and the length of B, okay, this endpoint here would touch the base of the triangle twice. Right, once here, the second time here. Okay, if we connect this point here with this corner, we'll have one triangle, and this angle would be an obtuse angle. Right, so we have one former triangle looking like this, right? And if we connect this point to this corner, right, ignoring all these lines here in the middle here, we'll have another triangle looking like this. Yeah? Let me label the sides. Okay, this is side B. This edge here is side A. And this is the angle that's given to us. Okay. So we didn't change the size of A, right? By saying we didn't change the size of A, I mean that all these three quantities, right, the magnitude of the side B and side A and the angle, all of these three information are given to us in the question, right? So all we did was to change the orientation of the side. Okay, we just placed the edge here and here. Right. By doing so, we have formed two triangles. Okay, what's different though? This angle is different than this angle. Right. This angle is obviously bigger than that angle. Okay. This base here is clearly different than this base. So we have two completely different looking triangles with different sizes of angles and base. Right? This is why we have two triangles. When the side length of A, right, the length that is opposite to the angle that's given to us, okay, when this side length is in between the length of H, which is the height of the triangle, and the length of B, which is the side that's given to us. Okay, this is our third case, the case with two triangles. Okay, so this is the whole idea of the ambiguous triangle. Okay, by comparing the length of the side that's given to us, that's across the angle that's given to us. Okay, by comparing that side with the height and the side, the other side that's given to us, okay, we will have three cases. Okay, now the question is, how do you find this H though? Okay, we know that B is given to us. We know A is given to us. How do you find H? Well, looking at this H here, okay, we know that B is given to us. Okay, I'm repeating myself again. B is given to us. A is given to us. If we look at only this part here, we have a right triangle. Right? This is H. This is B. This is angle A. Okay. If we use SOHCAHTOA, right, what's the relationship between these three things? This H here is opposite to angle A, and B is simply the hypotenuse of this right triangle. So if we are to use one of these three to describe this relationship, we're going to use SOH, because sine of A is opposite, which is H, over hypotenuse B. So let me write it out here. Here we have sine of A equals opposite over hypotenuse. Opposite is H. Hypotenuse is B, right? Since we want to find H, we're going to isolate H. So removing this B here by multiplying both sides by B, we have B times sine of angle A. This equals H. Okay, so this is how we find H. And we now have a pretty general concept of how the ambiguous case works. And let's jump back to our original question. Okay.
Alright, thank you so much, sir, for the slow and steady explanation. I really appreciate your help. Till then, I shall see you all in my next video sharing. Bye bye and have a nice day.